Mercury, the smallest and innermost planet in the solar system, is a world of extremes and contrasts. While it is often overlooked in favor of more distant and enigmatic planets, Mercury holds a fascinating collection of mysteries and scientific importance. It is the closest planet to the Sun, and despite its proximity to Earth, Mercury remains one of the least explored bodies in our solar system. In this introduction, we will delve into Mercury's physical properties, its orbit and temperature fluctuations, its historical significance in both scientific and cultural contexts, the challenges of exploring Mercury, and its place in the broader understanding of planetary science. Mercury is a rocky planet, also known as a terrestrial planet, meaning it shares certain features with Earth, including a solid surface, mountains, valleys, and craters. Mercury has a diameter of 4,880 kilometers, about 3,032 miles, making it just slightly larger than Earth's moon and about 38% the size of Earth. Despite its small size, Mercury has a surprisingly dense core, contributing to roughly 80% of the planet's mass. This dense core is likely composed of iron, and it is believed to be responsible for Mercury's strong magnetic field. The remaining part of Mercury is made up of a rocky mantle and crust. Mercury's surface is heavily cratered, with features resembling both the Moon and other terrestrial planets. It has vast plains scarred by the impact of meteorites over billions of years, and a variety of unique surface features such as high cliffs known as lobate scarps and volcanic plains. The surface temperature can range from an extreme heat of 430 to 800 degrees during the day to a bone-chilling 180 to 290 degrees at night, making it one of the most temperature-variable planets in the solar system. Mercury has a very thin atmosphere, or more accurately, an exosphere, composed mainly of oxygen, sodium, hydrogen, helium, and potassium. This exosphere is extremely tenuous and is constantly being replenished by the solar wind, a stream of charged particles emitted by the Sun. Due to the lack of a substantial atmosphere, Mercury is unable to retain heat and experiences drastic temperature changes. Despite its small size, Mercury has a magnetic field about 1% the strength of Earth's. The field is generated by the planet's molten iron core, similar to Earth's dynamo effect. This magnetic field is unique and plays a crucial role in protecting the planet from solar wind, though not as effectively as Earth's magnetosphere. Mercury's orbit and rotation are among the most unusual in the solar system, and understanding these phenomena is key to comprehending the planet. Mercury is the closest planet to the Sun, orbiting at an average distance of about 58 million kilometers, 36 million miles. Its orbit is elliptical, meaning that its distance from the Sun varies during its revolution. A year on Mercury, defined as the time it takes for the planet to orbit the Sun once, lasts only 88 Earth days. Mercury's rotation period is remarkably slow. It takes about 59 Earth days to complete one rotation on its axis. However, because of its unique orbital resonance, a single day on Mercury, from one sunrise to the next, lasts about 176 Earth days. This means that a day on Mercury is nearly twice as long as its year. The combination of Mercury's slow rotation and its lack of a substantial atmosphere contributes to extreme temperature fluctuations. During the day, temperatures can soar to 430 degrees Celsius, while at night, they can plummet to 180 degrees Celsius. The lack of a thick atmosphere means there is no medium to store or redistribute the heat across the planet. Mercury was first observed through telescopes in the early 17th century, but the planet remained a mystery for much longer due to its proximity to the Sun and the challenges posed by its harsh environment. Galileo Galilei, one of the first astronomers to use a telescope for observation, was aware of Mercury but could not study it in detail due to the planet's proximity to the Sun. Later, astronomers like Johannes Kepler and William Herschel contributed to the understanding of Mercury's orbit and characteristics, though the lack of direct observations left many questions unanswered. The first spacecraft to visit Mercury was Mariner 10, launched by NASA in 1973. Mariner 10 was able to observe Mercury's surface and map about 45% of it before its mission ended in 1975. The next significant mission was NASA's MESSENGER, Mercury surface, space environment, geochemistry, and ranging. which orbited Mercury from 2011 to 2015, gathering vital data on its surface, magnetic field, and environment. In 2025, the European Space Agency, ESA, and JAXA, Japan's space agency, plan to launch the Bepi-Colombo mission, a collaboration to study Mercury in greater detail. This mission will build upon the data collected by MESSENGER and offer new insights into the planet's composition and magnetic field. Mercury provides critical clues about the processes of planetary formation and evolution. As one of the most ancient planets in the solar system, its surface and structure offer a snapshot of conditions in the early solar system. The high concentration of iron in its core is particularly significant for understanding the processes that led to the formation of rocky planets. Several theories exist regarding Mercury's dense core. One prominent theory is that the planet may have formed with a much larger mantle, but that it was stripped away by a massive collision with another celestial body early in the solar system's history. Another theory suggests that the solar wind, which is particularly strong near the Sun, may have played a role in stripping away Mercury's outer layers. Mercury, along with Venus, Earth, and Mars, is considered a terrestrial planet. But it is significantly different from the other planets in terms of its size, density, and surface conditions. Comparing Mercury to these other planets offers insights into the factors that shape planetary evolution. The planet's proximity to the Sun, for instance, makes it a valuable object of study for understanding how solar radiation impacts planetary development. Throughout history, Mercury has captured the imagination of various civilizations. Its rapid movement across the sky and its position closest to the Sun made it a symbol of speed and change. In Roman mythology, Mercury, known to the Greeks as Hermes, was the messenger of the gods, symbolizing swift communication and the exchange of ideas. This connection between Mercury and speed is reflected in the planet's rapid orbit around the Sun. In many ancient cultures, Mercury was associated with duality, travel, and trade, symbolizing the dynamic nature of human life. Mercury was also studied for its position in the heavens. In the 17th century, astronomer Johannes Kepler famously used Mercury's movements to support his laws of planetary motion, particularly the concept that planets orbit the Sun in elliptical paths. Studying Mercury presents unique challenges due to the planet's proximity to the Sun, intense heat, and the difficulty of observing it directly from Earth. Despite these challenges, Mercury is an important subject of study for understanding the solar system's early history, the dynamics of planetary systems, and the processes that lead to the formation of planets. Innovations in space technology, such as improved spacecraft instrumentation, new propulsion techniques, and innovative methods of data analysis, have opened new possibilities for studying Mercury. Upcoming missions like Bepi-Colombo aim to overcome the obstacles that have limited our understanding of this fascinating planet. The study of Mercury has broader implications for the study of exoplanets. Planets orbiting close to their stars, much like Mercury, are common in other solar systems. Understanding Mercury's environment and the processes that shaped it can provide valuable insights into the evolution of similar planets in distant star systems. Mercury is a planet of extremes, hot, cold, and craggy. Yet it plays a pivotal role in our understanding of the solar system. Through the study of its composition, history, and behavior, scientists can unlock crucial details about planetary formation and evolution. As new missions provide additional data, Mercury's secrets will continue to enrich our knowledge, not only of the closest planet to the Sun, but of the broader processes that govern planetary systems across the universe.